you know, insulin is a peptide hormone. And that's her, you know, that's her, you know, that's her results in anabolism. And obviously anabolism means synthesis of many things, such as synthesis of glycogen, synthesis of triglycerides, and indeed synthesis of proteins. So insulin, the target, you know, its target organs are mainly the liver, well, not mainly, the liver, muscle, adipose. So when I say liver, I mean hepatocytes and adipose tissue. So really, before I even talk about the signal transduction of insulin, I need to return to, you know, how insulin is synthesized and secreted. And indeed, this obviously links back to the introduction to the GI talk, which, you know, talked about the pancreas as well as the blood supply to the pancreas, and indeed how, you know, how venous blood is then collected from, well, venous return from the pancreas, you know, via the, you know, well, venous return from the pancreas merges with, you know, is part of obviously venous, SMA venous return, so which is SMV venous return, as well as IMV. This is superior mesenteric vein, inferior mesenteric vein, and indeed splenic vein. They all merge together into the portal vein, which then delivers the venous circulation into, from the GI tract into the liver. And that venous return will have, you know, that portal blood will have insulin secreted into it from the pancreas. So really, if I perhaps just ever so quickly just say insulin synthesized in the pancreas. And obviously the pancreas has, so pancreas has an exocrine function and an endocrine function. So pancreas is obviously a gland function. So really the exocrine function is not what I'm talking about, but the exocrine function is involved with HCO3 bicarbonate secretion from the epithelium, and the secretion of pancreatic juice, which are pancreatic enzyme, pancreatic juice, all of which are secreted into the second part of the duodenum, i.e., you know, the GI tract, and they are involved in digestion, etc., you know, and absorption of, you know, nutrients that we eat. Then the endocrine function is what I'm specifically focusing on today. So, and this involves hormone synthesis and secretion. So when you talk about the endocrine function of the pancreas, the hormones that we're talking about are actually, before I even talk about the hormones, I must really say that this is done by the acinar cells, because I did mention that this is from the membrane, you know, epithelium. So the hormone synthesis is from the islets of Langerhans, So the islet really can be oval or round shaped, and it has different types of cells within it, and these different types of cells are involved in the synthesis and secretion of different hormones. For example, we have the beta cells, which mainly secrete insulin, C-peptide, amylin, and proinsulin. And then we have the alpha cells, which mainly secrete glucagon, the hormone. And then we also have delta cells, which mainly secrete I shouldn't do this right, never mind. Somatostatin. And then we have F cells, which secretes the pancreatic polypeptide. So the way I've drawn these cells also really in a way defines their arrangement. The beta cells that I'm mainly talking about at the moment today, well, in this talk, I don't know how many talks I'm going to make today, are much more central. So this is the islet of Langerhans. So they are much more central, and then the other ones are much more on the outer aspects. So really, the reason why I'm talking about the fact that they are much more central is because blood, when blood is flowing, within the islet, it sort of flows from the central aspect to the peripheral, and that means that that blood, the venous blood obviously, is already carrying insulin as it moves towards the peripheral, and that then means that because there is insulin in that blood, then all these other cells are then inhibited from secreting their hormones. So this is quite important, really, because really, if insulin is quite important, for the synthesis for energy needs, and as well as for synthesis of and storage of a lot of things such as glycogen, triglycerides, and indeed protein, and obviously for growth as well. So if there is no insulin being carried in the blood, then that releases the alpha cells to secrete glucagon, which then causes catabolism of all those stored materials, such as stored glycogen, then undergoes metabolism to then release the glucose that is needed for cellular processes. So really, the aim really here is just to show that the blood flow of the islet of Langerhans in a way helps these cells to communicate one another, and indeed these cells do communicate with one another so that they know when to secrete their hormones in order to for body processes. So really, this is a nice way of how the cells of the islet of Langerhans regulate themselves and communicate with one another through gap junctions and tight junctions, which I've already talked about, in order to release the hormones. So now that we know that insulin is made in the pancreas and indeed by the beta cells of the eyelets of Langerhans. The next stage is just to talk about really what is insulin itself. So insulin is a peptide hormone, obviously I've already said that, and it's encoded in short arm. So I'm just going to say P for petite, short arm of chromosome 11. And really its synthesis is quite okay. I'm actually going to discover it in space to tell what its synthesis. So insulin synthesis is highly, linked to glucose. So when one consumes glucose, the body receives, a message. Really, glucose immediately causes the release and indeed the synthesis of so it's like immediate release from the storage and synthesis of insulin. It's a market change really within I think the glucose tolerance test is based on this, in the sense that obviously I'll redo this at some point. So if we're to look at a graph of insulin versus glucose, we'll find that if this was, consumption, okay, this will be ours, this will be glucose, and this, okay, and this will be insulin. So if one consumed, like glucose, a meal that contains glucose, so you have something like this where there's a load of glucose, and then that, and insulin secretion, goes like this. So it works to reduce glucose, basically. And obviously this is insulin, it's measured in micro units per millimole, and glucose is obviously measured in millimoles per deciliter. So, but then the point really is that, within, this is even much more to the left. So within, a few hours of consuming glucose, insulin would have been released to reduce that glucose. So really no one remains at a hyperglycemic, which is high glucose level. And this then, the reduction of that glucose in the blood following insulin secretion then is the basis for diabetes, diagnosis, because really following consumption of glucose, insulin normally is produced, and if someone remains hyperglycemic, say if they remain like that, and their glucose doesn't really go, reduce following a few hours after consuming that glucose, then that person remains at a hyperglycemic state, and obviously it means that for some reason they are not perhaps secreting any insulin, which could be type 1 diabetes, or if they are indeed secreting insulin, then it's not really working their cells have lost any sensitivity to insulin, which obviously is more type 2. But then anyway, I will talk about this at another time. But this really is, particularly this is the basis, you know, for that diagnosis for diabetes, which is a, you know, hyperglycemic state. So insulin synthesis and secretion. So I don't know why I'm picking green. It's quite straightforward, really. As in, it's made in a few steps, you know. Number one, once you know that once DNA has been, you know, synthesized from the chromosome, and then